2223 sum of scores of building streets. So for this problem, we are giving a string S, and according to the problem, we are going to return the sum of the score of every fi. So this means we're gonna check each of the places. So for example, we have the string like BA and BAB. Yeah, we're gonna check every places. So for the first place, yeah, we just need to check this BABAB. If it is equal to this BABAB, if it is equal, yeah, definitely the first place will always equal. So it's gonna be a 5. And then we're gonna check the next index. So for this index, we're gonna starting from ABAB, but the first place is B. It is not A. So definitely this score gonna be 0. So 5 plus 0. And then we're gonna check the next character. It's gonna be B. So B, this is also B, and this is A, and this is A, and this is B, and this place is also B. Yeah, it seems we are just checking this window and this window. They are the same. So it's gonna be a 3. Next, we're gonna check this character A, but the first place is B, so it's gonna be a 0. So for the next, it is a B, and this character is a B, so it's gonna plus a 1. So the final result is gonna be 9. Yeah. So according to this kind of definition, actually this is a string matching problem, and it is exactly the same as the z function. So today we're gonna talk about what is the z function and how we can use the z function to solve the problem directly. Yeah, because this is just a template problem about z function. So if you didn't know about z function, it is still okay. You can use a KMP to solve the problem. Yeah, basically for most of the string matching problem, basically you can use a KMP to solve it. Yeah, but today we're gonna use an advanced algorithm. It is a z function. Basically, z function is the idea of z function is get from the KMP. Both of them will be just O(n) time. So definitely we cannot use the O(n) squared to solve the problem. Yeah. So for the KMP algorithm, basically we are just needed to create an array. So for the KMP, the prefix should equal to the suffix. Yeah, but for the z function, it is a little bit different. So it means the prefix should equal to the prefix. So for example, starting from this place in B, so this prefix BAB should equal to the prefix of our string BAB. Yeah, so this is why the value is 3. Yeah. So this is a really good article to let us understand what is the z function and how to calculate and how to get the template code. Yeah. So according to the definition, we can understand it from here. So the z function, so for this string of an array of less n, so where the ith element is equal to the greatest number of characters starting from the place in I that coincide with the first character of S. Yeah, this may be really difficult to understand because while we are checking some really new definition for z function, we don't understand it. Let's just use some examples to understand what it means. So for this string AAAAA, we're gonna get a z table, so it's gonna be 0, 4, 3, 2, 1. But why it is? We're gonna check the index one by one. But for the first place, we're gonna set it as a 0 because there's no meaning. So we're gonna set it as a 0. Yeah, because basically while we are checking this array, we're gonna start it from index 1. But for the first place, we just give a 0. Yeah, and then we're gonna check the second index for this A. We're gonna check how many A's for this substring 1, 2, 3, 4. And then for this whole string starting from this A, is this AAAA equal to that AAAA? It means yeah, we're gonna have an index of 4. Yeah. So if the prefix of our current, if the prefix of the substring equals to the prefix of our string, so our string is this S. So we're gonna have this index I, it's gonna be 4, and for the next one, it's gonna be 3 because it's 3 A's, and from the first place, it's gonna be 3 A's, and then 2 and 1. Yeah, and let's just check the last example. So this is A, the first place is gonna be 0, and then we're gonna check the second index. Yeah, so for this B, it is a 0, and then we're gonna check the third index. It's gonna be A, but this is A, it's gonna be 1. Yeah, because for the next one, it is a C, it is not equal to B. Yeah, and then continually, we're gonna check the next one. For example, this A. So this is ABA, and this is also ABA, so it's going to be 3. And for this B, it is not equal to A, so it's going to be 0. And the next, so this is A, and the first place is A, so it's going to be 1. Yeah. Basically, we need to get such kind of array. If we can get such kind of array, we've already solved the problem. But we cannot get it by using O(n) squared time. We have to use O(n) time to solve the problem. Yeah. So this algorithm is a basic calculation of O(n) squared. So this is C++, and we can also use we can also check it from here. So I put it in my program. Yeah, I just turned the C++ to Python. So from here, we can understand this is a naive solution, so it's going to be O(n) squared time. Yeah, so basically, we are using this kind of O(n) squared to understand why we can turn this one to O(n) time. Yeah. We are going to get such kind of array. So we're going to start in from the second index, which means it's going to be index 1. Because for the first index, it doesn't matter. We're going to set it as 0. And then we're going to check the I plus zi. According to the array, this I plus zi, if it is inside the boundary less than n, and if the string as zi equal to si plus zi, so we're going to update this zi. Yeah, we're going to always update it. Yeah, if there's a duplicate. Otherwise, we're going to check the next one. Yeah, so this is the basic idea. So for example, if we are going to check this string as 2, yeah, so for the first a, we're going to set it as 0, and for the second a, it is this a. So we're going to check it inside the while loop. If this a equal to the first a, so the zi would plus 1, so it's going to be 1 here, and then we're going to check the next a. Yeah, so if this a equal to this a, so we're going to plus 1, it's going to be 2, and then we're going to check this a, the next a, so this a equal to this a, so it's going to be updated to 3, and then we're going to check next, because a not equal to b, so we're going to stop here, and then we're going to update all the index like this. Yeah, but this will be O(n) squared time. Definitely it cannot be used to solve the problem. Yeah, so the advanced way is to use the z function. So this is the basic idea of how can we use a z function to solve the problem. I think you can check the links. For this website. Competitive programming algorithms website to check the z function, and basically if you read it, you're gonna understand why we're gonna use it to solve the problem. Yeah. So the basic idea is we're gonna prepare a box. This box is gonna have a left and a right boundary. So we're gonna check if the our current index is inside the boundary, so it is okay. We can jump. It is similar like the KMP. We can, we don't need to repeat the previously calculated result if it is inside the window. So this is gonna be left and right window or left and right box. But if it is more than the box, so we need to update the left and right index. Yeah. So here for this I more than or equal to r, so basically this is gonna be the naive algorithm. Yeah. It means we're gonna check the while loop. Yeah. But if it is less than r, it means it is inside the boundary. So because there's a match, so we don't need to check one by one. We can update it directly. Use the zi minus l. We can get the result. Yeah, basically I think you need to understand this well. But here we need to check the boundary. It's gonna be r minus I. So it's gonna be the minimum of r minus I. So yeah, we are giving this example. So for this string, if the index is 6, it's gonna be this last a. Yeah. So for this last a, our current window is from current box is from 5 to 7. So this 5, basically this 5 is 0, 1, 2, 3, 4, 5. Yeah, this 5 is this a. Yeah, and this 7 is just go outside the boundary, the last one. Yeah. So this is 5 and 6. So the position 6, it means the last one, will match position 6 minus 5. Yeah. So it's gonna be match position this position 1. Yeah. So the match is divided by this one, zi minus l. So the I is 6, l is 5. So 6 minus 5, it is 1. So z1 is gonna be this a. Definitely, yeah, this last a gonna match this a. Yeah. So if it matches this a, what's gonna happen is it's gonna be z1. But our z1 is calculated before, and it is 3. But of course, this position cannot be 3 because this position should be 1. For the last position, this is Z6 gonna be 1, but it is 3. Of course, it is not right. So this means we have to check the window if it goes outside of the box or not. Yeah. So yeah, so currently this Z1 is 3. We cannot initialize this Z6 to 3. Yeah, it is not right, because the maximum value, if we try to understand the z function, it's going to be 1. Yeah, so this means we need to check the index. If it is beyond the boundary of L and R, we need to use this R minus I to control if it is inside the boundary or not. Yeah, but basically for this Zi minus L, it has already, yeah, this 6 minus 5 Z1, it is 3. Yeah, but for this yeah, it is 3, so we cannot directly use Zi minus L to check. We have to control it by R minus I. Yeah, I think this may be the difficult part of the algorithm. So it has to be inside the boundary. And then this is just the algorithm. We can directly use it to solve the problem. Yeah. So here is if the right boundary is more than R, we're gonna update the left and the right side. Yeah. Now we're gonna use this kind of idea, this z function idea, to solve the problem. Yeah. Now let's just use the z function to solve the problem. So we're gonna define a z function, and inside it's gonna be string s, and we're gonna check the length of the string, and we're gonna check the z function left and right boundary. So the z function gonna be 0 times n, and the left boundary and the right boundary gonna be 0 from the beginning. Yeah. Now let's just write the naive solution first. So it's gonna be a for loop. It's gonna be from the index 1 to n. So it's gonna be, then it's going to be a while loop. Yeah. If I plus zi, it is inside of the boundary less than n, and si, inside is going to be zi equal to the next value. It's going to be si plus zi. So we're going to update the zi plus equal to 1. Now we're going to check the I plus this zi. If it is more than the right boundary, we're going to update the left and the right boundary. So the left boundary going to be I, and the right boundary going to be I plus zi. Finally, we're going to return this z array. This z array is going to be here. Yeah. But before that, we need to check if this index I is less than the right boundary. It means everything is inside the boundary, so we can jump. So the jump gonna be, we can update the zi. It's gonna be the minimum, as I said before. This is a little bit difficult to understand. We have to control that. It's gonna be r minus the current I, with the z I minus the left boundary. Because this one is basically, we don't need to check the while loop again and again. If it is less than r, we can directly calculate this zi. So after that, we don't need to repeat this while loop anymore. Yeah. Now we just need to check the result if it is okay for our z function. So it's going to be z function. We're going to put the s inside. Finally, we're going to return the length of the result, the length of the string. Yeah, because for the first one, this BABAB, we didn't consider it in the z function. We always start from the index 1. But for our for this problem, we need to start from index 0. So this means we're going to plus length of the string, and then we're going to plus the sum of the result. Yeah. But before that, let's just check what is the result, if it is right. Yeah. Now, as you can see, it works. And this is going to be the z array. So from here, we calculated this Z array, and basically we calculated everything according to this article, and all my algorithm is deducted, transformed to Python, transformed from this C++ to Python according to this article. Yeah, basically whether you're gonna use C++ or Python, definitely this is a really good reference to solve the problem. Yeah, so here this is the Z function, but actually we calculated just use on time instead of on square. If we don't have this one and this one, it's gonna be on square. But as we control the box, the left and the right boundary for the box, we're gonna make the algorithm become just on. And the result gonna be the Z array. As we can see it for this string, the first place is going to be 0, and then we're going to check it, it's going to be 0, 0, and for here it's going to be 3, because this is A, Z, and B, and this is A, Z, and B. This is why the index is going to be 3. Yeah. Now let me delete the print and submit it to check if it works. Yeah, as you can see it works, and it's pretty fast. Thank you for watching, see you next time.